Dr. Rashid, we are starting with the live. So you please come online. You can present your share your presentation.
Okay, ma'am.
A very good morning to all the participants who have joined us on the YouTube. I'm Dr. Swati Gupta, Deputy Secretary Skill Unit CBSE, and I welcome you all again on the second day of Geospatial Technology Teachers Training Program arranged by the board. Today we are going to be dealing with the class 12th content of CBSE book, and then we will have a practical demonstration on the selected topics by Dr. Mohammad Rashid. Dr. Mohammad Rashid is our expert on geospatial technology, and now I'll ask him to please come and take up the session. Thank you. Dr. Rashid,
Yes, ma'am.
please start with your session.
Hello, everyone. This is Dr. Mohammad Rashid. I'm Today we will learn about remote sensing and GIS, which will cover the two chapters of Geospatial Technology book. It is chapter number 1 and chapter number 2. First, we will know about remote sensing. Then I will discuss some important points related to GIS. So let's start with the remote sensing part. Remote sensing is the helps us to collect information about different features of the Earth's surface without touching it or without coming into contact with these features of the Earth's surface. Nowadays, remote sensing has several applications in different fields. This, after the development of satellite sensors are used to capture the information of the Earth's surface, and these sensors records the reflected or emitted energy from the features which are applied and used to process the information from the images captured by the sensors. The fundamentals behind the remote sensing is that every object we found on the Earth's surface either emits energy or reflects energy, which provides us a communication link between the object and the sensor. This is the basic fundamental which is used or applied in the remote sensing technique to collect information about different features and objects of the Earth's surface. There are certain processes and steps involved in the remote sensing technique which we have to follow. These steps are an essential part of the remote sensing, without which we cannot capture the information about the features of the Earth's surface. The first requirement for remote sensing is we need a source of energy. Either it will be located within the sensor or outside the sensor. In fact, our solar system, sun is the main source of energy. The sun emits energy in terms of electromagnetic radiation. These radiations passes through the atmosphere, where these radiations interact with the gases and particulate matters present in the atmosphere and other weather conditions. These particles either absorb or scatter these solar radiations. The remaining part of the solar radiation reaches the Earth's surface and interact with the different objects differently. It is either reflected or transmitted or absorbed by the object. It is the reflected energy, which is the energy reflected by the object is the most important in the remote sensing process, which is intercepted, which is recorded by the sensors and transferred to the remote sensor stations located at the ground. Then these data are interpreted, analyzed, and applied for different purposes. As you know, the electromagnetic radiation is the most important component in the remote sensing technique. Therefore, it is important to study this feature, the features of the properties of the electromagnetic radiation in detail. Electromagnetic radiation, as we know, composed of electric fields and magnetic fields. The electromagnetic radiation has the property of the electromagnetic radiation, which is important in remote sensing technique, are the wavelength and frequency. These are the most important properties of the electromagnetic radiation, which is important in the collection of data through the technique of remote sensing. as these properties indicates about different objects and interact with different features of the surface differently. As we know that the wavelength and frequency are inversely related to each other. When the wavelength is shorter, the frequency is longer. And when the frequency is longer, then the wavelength is shorter. Therefore, understanding the characteristics of electromagnetic radiation in terms of their wavelength and frequency is important for remote sensing data collection. Electromagnetic radiation is composed of different spectrum. Either it is composed of visible band, ultraviolet band, and infrared band. As it is given in the picture, in remote sensing, it is the visible band and infrared band which is particularly important for collecting data. The remote sensors collect information about different features of the Earth's surface, particularly in two bands of the electromagnetic spectrum. The second step when the in the remote sensing is that when the solar radiation or electromagnetic radiation passes through the atmosphere, it interacts with the particles and gases present in the atmosphere in different ways. Which reduces the amount of energy to reach the Earth's surface. The processes which affects the solar radiation in the atmosphere are basically of two types. These are scattering and absorption. Scattering occurs when the particles or gases redirect the electromagnetic radiation from its original path. The amount of the quantity of scattering depends on the several factors such as wavelength of the radiation, amount of particles present in the atmosphere at a time, at a particular time, and the distance of the path traveled by the by the radiation in the atmosphere. In the atmosphere, we observe three types of scattering which takes place, which affects the incoming solar radiation. It is number one is the Rayleigh scattering. It occurs when the gas particles are smaller than the wavelength of the radiation. These particles include specks of dust or nitrogen oxygen molecules. Rayleigh scattering basically affects the shorter wavelength. This is why the sky appears blue, because it is due to the mechanism of Rayleigh scattering, due to which a sky appears blue. Second type of scattering is Maya scattering, and third is the non-selective scattering. Maya scattering occurs when the particles are of similar size to wavelength. It includes a smoke, water vapor, etc. Maya scattering basically mainly affects the longer wavelengths than shorter wavelengths. It mainly occurs in the lower portion of the atmosphere, where these particles are available in a larger amount, and other weather conditions like cloud dominates the atmosphere. In case of non-selective scattering, the particles present in the atmosphere are much larger than the wavelength of the radiation. It includes like water droplets, particulate matters, etc. This type of scattering due to this type of scattering, the fogs and clouds appear to us as white. Absorption is the another important mechanism which affects the incoming solar radiation into the atmosphere. This this mechanism absorbs the incoming energy, absorbs the solar radiation by in various wavelengths by different gases and other particles present in the atmosphere. However, it is the process of absorption basically takes place by the water vapor, ozone, and carbon dioxide. These are the major constituents, these are the major gases which absorbs the incoming solar radiation. The process of absorption takes place in the in a particular region of the spectrum. Therefore, it is important to therefore it affects a particular region of the spectrum. Therefore, it is important to look in a particular region of the spectrum for remote sensing purpose and to obtain a quality data about different features of the Earth surface. And the region of the electromagnetic radiation which is not affected by the atmospheric absorption are useful to remote sensors, and this is known as the uh, energy which is not absorbed by the atmosphere is known as the atmospheric windows. These atmospheric windows are important to collect information from remote sensing images and data captured by the remote sensors. Using the atmospheric windows, we can define the wavelengths that we can use in remote sensing. The visible band of the spectrum is particularly important zone, and we are accustomed to these lights. So it also passes through the atmospheric window. Therefore, this is used for in remote sensing. The radiation which is not absorbed or scattered in the atmosphere reaches the Earth's surface and interacts with different objects, different features of the Earth's surface, in different ways. But the incoming solar radiation interacts with the different objects of the Earth's surface mainly in three ways. It either it will be in terms of transmission, absorption, or reflection. The proportion of absorption, transmission, and reflection by any object depends on the wavelength of the energy, incident energy, chemical composition of the feature, and physical properties of that feature. These are the factors which decides whether an object absorbs the incident energy or transmits the incident energy or reflect the energy. Absorption occurs takes place when it is absorbed by the source, by the object, and when the energy is when energy passes through the target, it is transmission, and when an object redirects the incident energy, it is the reflection, which is particularly important in the remote sensing. It is the reflected energy which is important to collect information about different objects of the Earth's surface using remote sensing technique. The objects of the Earth's surface reflects the energy in two ways. Either it will be a specular reflection or diffused reflection. Whether an object reflects specularly or diffusely depends on the roughness or smoothness of the feature of the object. In a specular reflection, when the incoming solar radiation interact with a a coarse object, it redirected to a fixed direction at a fixed angle, as we can see in the first picture, where a road has been shown, and in case of diffused reflection, in this we can see in the picture, which shows that leaves of tree, which is smoother than the road surface, redirects the incident energy into different directions. Most of the objects of the Earth's surface are lies between somewhere between specularly or diffuse reflectors. When the wavelength of the incoming energy or incident energy is much smaller than the particle size of the surface, then diffuse reflection will dominate. And when the wavelength is higher than the particle size of an object, then a specular reflection dominates. We can understand this by an example which is given here. A fine grain sand will appear smoother, smooth, smooth to us in a long wave microwaves, but the same sand will appear to us rough, invisible band. We can also understand this by the example of leaves. As we know, in leaves, a chemical compound is present known as chlorophyll, which absorbs the wavelength in red and blue region wavelength, and it reflects the green light. As a result, it appears to us greener. When the content of chlorophyll is higher, then it appears the leaves appear to us more greener. It means we can, through this mechanism, we can use this technique to analyze the health of the vegetation or crops. The internal structure of healthy leaves function as diffuse reflectors, which reflects near infrared wavelengths. If an if a human eye is sensitive to near infrared band, then it appears extremely bright to us. So, by monitoring the infrared reflectance from the vegetation, we can determine or analyze its healthy, its condition, the quality of vegetation, whether vegetation require some treatment or improvement or not. Depending on the reflectance Depending on the amount of reflection from different objects, we define the spectral reflectance or a spectral signature of different objects of the surface. The spectral signature of different objects varies with time and location. Time and location of any object defines the spectral reflectance of that object. Percentage of reflectance depends. It is the wavelength that defines the spectral signature of different objects. It is critical to understand and interpret the electromagnetic radiation of different objects. Now we will learn about different types of sensors used in remote sensing to collect information about the different features of the Earth's surface. The sensors used in the satellites in the remote sensing are basically of two types: passive sensors and active sensors. Passive sensors capture. Passive sensors works during in the during the daytime, and it measures the energy available naturally available. Passive sensors can only work when the natural light is available. However, the infrared energy, which is naturally emitted by all objects of the Earth's surface, can be detected during day and night time. If someone want to measure or record the infrared energy during night time, then the recording or collection of quality of data depends on the availability of amount of energy. It should be available in the large amount, so we can be able to record the information accurately about the object. In case of active sensor, the source of light is located within the sensor. These sensors emits energy towards the object, which is reflected by that object, and it is reached. It reaches the sensor, recorded by the sensor, and processed by the remote sensing station. The advantage of active sensors is that we can obtain data anytime and in any season. The season and time do not affect the quality and amount of information, the information collected by the active sensors. Now come to, we will know about remote sensing data product. Remote sensing data products are basically of two types. It is depending on the source of technique used for collection of information. When the data is captured by ground or aircraft based platforms, then it is produced in the form of images, paper photographs, which needs to be scanned and included, stored in GIS. In case of digital data, these data are directly transferred to the computer system, and there is no need to produce paper photographs. Digital data are basically of two types: digital camera imagery and satellite imagery. Digital camera imagery collect the information using the digital digital camera, which are mounted on a ground or air-based platforms. The information collected by these cameras are directly stored in a digital form, which we can transfer directly to the computers for analysis purpose, and we can apply this data for different purposes. In case of satellite imagery, these satellite sensors, the satellite sensors mounted on satellites records the reflected electromagnetic radiation and convert them into digital numbers. These digital numbers are transmitted to the ground station, where these numbers are converted to pixels. Pixels, what are the pixels? Pixels are the smallest unit that which is captured by the digital camera or sensor. Then these pixels are arranged into a matrix format, which gives us a complete information about a particular location or about the objects of the Earth surface in which we are interested to collect information about. The quality of these pixels depends on the resolution. It means higher the resolution, better will be the picture. When the resolution of pixels are higher, The pictures obtained is of higher quality. When the resolution of these pixels are lower, then the data in, obtained from these images, satellite imageries, are of poor quality. Resolution, therefore, we can say that resolution is it is important to understand the mechanism of resolution. So, resolution is the ability of sensors to collect information about the smallest object on the earth. It may be either in terms of distance, electromagnetic radiation wavelength band, time, and quantity. Depending on these features, however, the smallest object identified by the sensor cannot be smaller than the pixel size. Depending on the distance, EMR wavelength band, time, and quantity of the resolution is of four types. These are spatial resolution, spectral resolution, temporal resolution, and radiometric resolution. A spatial resolution. The minimum area detected and measured by the sensor is known as the spatial resolution. It is of three types: high spatial resolution, which falls between range between 6 to 4 meters; medium resolution; and low spatial resolution. The images, satellite imageries, falls within these three ranges. The satellite imagery may be of high spatial resolution, which captures the images up to 0.6 to 4 meters. The satellite imageries gives of low spatial resolution varies between it captures larger areas at a time. That's why it gives the data collected by these sensors are of poor quality. Now come to a spectral resolution. The sensing and recording of power of the sensor in different EMR bands. What is a spectral resolution? Is the power of the sensor to detect and record the information into different electromagnetic radiation bands. In case of radiometric resolution, it is determined by the number of discrete labels, and it records different in different bands of satellites. Then temporal resolution is the collection of imagery of some part of the Earth's surface at different period of time. So friends, I have finished the remote sensing part. Now we will learn about some important points of GIS. Geographical Information System, or GIS, is a software which we use to get to organize the spatial information and collect to know about the phenomena of the surface located in different parts, to know the characteristics of those features like distribution of land use, land cover, communication networks, population distribution. We can analyze both spatial data as well as non-spatial data through the GIS technique. Nowadays, GIS has been widely applied during the time of emergencies, like in the flood conditions, earthquake situation. These are used to locate and map the data in a visual way. We can visually absorb the information through the GIS software. Although a number of techniques are available for analyzing the data about the different characteristics of an area or region or a space, but we cannot use those techniques to visually observe the information about a location, about an area. As in GIS, data is produced in the form of maps, which make it convenient and user friendly, which can be used by a layman as well as an expert to understand about the location, about different characteristics of a region or an area. We can know about the number of schools and where the schools are located in a particular region, particular city, by looking into a map which is produced by a GIS technique, GIS software. So it has made helps us made easy to visualize data about a particular location, about different features of about that location. The the components needed for GIS are basically of five types. We need software and hardware. We need people to enter data and analyze the data. We need information or data for a particular location. This is, data is another important component of GIS software. Without data, we cannot use the GIS software. Data in GIS software included using different techniques and analyzed using different methods, and it is produced in the forms of map, charts, and tables. Now we will learn how to create a spatial data, create or include data into GIS software. We use several methods and techniques for including data into GIS software. These are: we use X and Y coordinates to input data into GIS when the spatial data is available in terms of X and Y coordinate. The another method is of data entry into GIS is using we can include incorporate data into GIS using the keyboard if information about some characteristics of a location like population, the types of crops grown there, the number of schools in a particular city are included into the GIS database through the database entry. Another method to incorporate data into GIS is the digitization technique. It is particularly important as we can correlate the non-spatial data with the spatial data using this technique. Digitization is basically of three types. It may be we can digitize an area, we can get information related if we have information related to the an area, then we digitize the whole area. If we have information, if our information is linear, like it is related to location of some schools or markets on a particular road, then linear digitization is used. And when the information is in terms of point or located at a particular, when we want to know about different characteristics of a particular location, then it is we digitize the point and include different attributes, different characteristics about that location, whether it is a school, whether it is a market, and what are the important features related to that market. We can all this information can be included using the digitization. Another data input to method to GIS is the scanning. When the data is available in term, when we have analog data in terms of paper map, then we have to scan these maps and georeference it into GIS, and we can add then we can add on the non-spatial features related to this map into the GIS software. In GIS software, data is stored in a spatial or non-spatial format. Spatial data include information about location, shape, and size, and relation between the features, whereas non-spatial data include information about the location, about the size of that spatial data. In GIS, spatial data is stored in two formats. It is a raster format and vector format. In case of raster format, the data is stored in terms of grid of cells, and these cells have some specific values according to the features, according to the characteristics related to those cells. In case of vector format, spatial data is stored using uh, in terms of point, line, and polygon. It means that data in vector format is stored in terms of either in terms of point or line or polygon. Polygons are used to add features about an area. When we want to analyze the characteristics of an area, then we use a polygon. This is these three are the basic fundamentals of the GIS, which are used to enter data which enter data into the GIS software. We have to clearly understand these terms when the polygons are used, when the lines are used, and when the point is used. When we want to know about an area, we have information about an area and want to visualize this information, want to portray this information through use polygons. For example, we want to know about soil types of an area. What are the soil types? Then we will use the polygons. If we want to know about the population of an area, population density of an area, then we will also use polygons. When we use lines, lines are used when we want to know about different features when the data is in the form of linear characteristics. When data is characterized by linear features like river, roads, district boundaries, then we use line for storing the data into GIS. And when the information is related to a particular location, particular point, we want to know about some important features of a particular point, like a railway station, an airport, or a market, or characteristics of a school, a particular school or college, then we use point. Then we store the data in terms of point. Now come to the data analysis techniques in GIS. In GIS, several types of data analysis techniques are applied. We can use different colors to analyze the data. We can also use the pie diagrams, bar diagrams to portray the data. We can know about the, we can portray the geological information into the map using different colors and lines. Buffer generation, buffer generation is used to generated around points, lines, and polygons. We use this technique to create new polygons by expanding or shrinking the existing polygons or by creating polygons from points. Then the technique of map generalization is used to remove unnecessary data so that we will be able to save the space for other data files. It simplifies the representation of data on a map at a certain scale with a defined and readable legend. We use another technique, digital terrain analysis, to analyze or derive. In this technique, we use point data to derive the slopes and watershed for watershed computation and identification and construction of different shades. This technique is applied to describe the basic visualization modeling, or it supports us in making decisions about some area. Another technique is of data analysis in GIS is the network analysis. We use network analysis when we want to route the resources along a set of linked linear features. When we want to route the resources optimally so that a resource reach the particular point at a shortest time, then we use network analysis. It helps us in solving the common network problem. The optimal path routing is applied to predict the best route between two or more points depending on distance, time, and another factors, so that using this technique we can route our resources and we can quicken make the ability of resources at a shortest time to the needy person. If we want to reach a point, a location at a shortest at a lesser time, then we can use this technique to identify the network through using which we can reach that destination at a short time. Therefore, this technique is particularly important during the emergency time, like at the time of earthquake, flooding, or at the time of accidents, railway accidents, etc. We can use this optimal path routing network analysis to select the shortest or the feasible route to reach uh, the destination quickly. Therefore, we can say that in this way, GIS helps us in several ways. Acquiring the knowledge of the GIS software is important for us, even for a it is also important for non-expert. We can use GIS technique in day-to-day life as we travel through, want to go through, we want to know about when we travel to a destination or a new town or a new city in a new area, we need to visualize where to go, where the tourist places are located, what are the important hotels in that area, where we will stay. So then this information can be visualized through the GIS technique. GIS techniques can be used by everyone to get information about a location, about an space in a very short time. Now I have finished my theoretical part. In the next part, that is a practical part, we will learn how to uh, know about how to locate any information into GIS software, how we can handle the GIS software. I will use QGIS software. You can learn, you can download this QGIS software from Google, and you may learn with me side by side. In the second session, we will learn about georeferencing technique and digitization of how to digitize a map using polygons, lines, and points, and then how we can export that image into. We also know in that particular practical class how to put legends, title of the map, scale, and other required elements into the map in a QGIS software, and then we learn how to export the prepared map into image form or PDF format. Thank you, everyone.
हेलो सर। हेलो
हेलो।
सर, 10 मिनट के ब्रेक के बाद फिर डेमो स्टार्ट कर दीजिएगा।
ओके।
ओके सर।
Good afternoon, Dr. Rashid.
Good afternoon, ma'am.
So, shall we start with the practicals?
Yeah, ma'am.
Okay, please
Actually,
start.
I'm welcome back to second session on practical part. In this session, I'm going to demonstrate how to use QGIS in and how to make georeference the maps in QGIS and use different digitization techniques to digitize area, line, and polygon. Then I will also show you how to put the title and different uh, factors required needed for a map, and after that I will show how to export these prepared maps into a JPEG image format and PDF format. So let's begin. This is the I have opened the shared the QGIS window. First, we need to first I am going to show you how to georeference a map. In this method, we will use two types of map to georeference the map. In case one, if when the coordinates, latitudes and longitudes are given on a map, then how do we georeference that map? It may be case that we want to georeference a map, we want to collect data of a map where the coordinates are not given. So in that case, it is quite difficult to georeference it. In that case, how to georeference that map, I will show you in this class. So let's begin. Go to raster located at the top and click on it. Then go to georeferencer and select it. A new window will open. Go to the open raster and click on it. It will take you to the folder and file where you have saved the map for georeferencing purpose. Here I am using Delhi. Click open. Then a dialog box will open. Here we have to select the projection system. You can select any projection by typing here. You can choose polyconic by or UTM. You can select any projection of your choice, but in this demo class, I will use World Geodetic System. In shorter form, it is known as WGS 84. Click on it, then click on OK. For georeferencing purpose, we have to select at least 4 points. A selection of a minimum of 4 points is must for georeferencing purpose. But if we select more than 4 points, it gives us a better result. After this, go to the transformation setting, and in transformation type, you can select any one of them, either linear, polynomial 1, polynomial 2, etc. In this case, I am going to select linear. You have to select linear. Then in resampling methods, a number of choices are given. It may be nearest neighbor, linear, cubic, etc. I will select nearest neighbor. We can again change our projection from here. Click on the output raster. Before selecting the points, we have to save the file. And give some name. Here it is. Give some name to the file, then click save. In output raster layer, click on this layer, this icon, and you can save your file from there. I have already selected it. Now click on OK. Now we can go to add points and select a dialog. As we click on the map, a dialog box will open in which it asks we have to put the values of longitude and latitude for that particular point. In X and East, we will put the value of longitude for that particular point. And in Y or North, we will put the value of latitude for that particular point. Now click OK. Then select another point. We have to select diverse points so that it gives better result. Click OK. If some point, if we mistake in putting the latitude and longitude value wrongly, correctly, then we can delete that point by clicking on delete point. Again, go to add point and select it and put the values for that point correctly. Click OK. Now I have selected 6 points. Now we will go to start georeferencing and click on it. Our map is now georeferenced. We can close this window, click on discard, as we have already saved this map. Now we will learn about the georeferencing of a map which do not have the coordinates. In this case, just first open a map which is georeferenced. Go to the raster layer and click on it. And click on the map which is georeferenced. Open it in this window. You may zoom it. Then go to raster and click on georeferencing. A new window will open. Go to click on open raster and select a map which does not have a coordinate. In this case, we'll georeference the map using some points which are identical in both maps. Just go to transformation setting and change or select some few attributes. Like in transformation type, you may select any one of the attributes, and in this case I will select linear. I will go for, in a resampling method, I will go for nearest neighbor. We have already selected the projection system. We have to say, give some name and save this file. Go to output raster and click on this icon. Give it some name of your choice. Click save, click OK. Now go to add point, select the add point, click at a point which is easily identified, which can be easily identified on the another map. Just click on that point. The dialog box asking for the values of latitude and longitude. In this case, we will, as we do not have the values of longitude and latitude, so we will click on from map canvas. Click on this button. and select the same point as we have selected in the previous map. The longitude, the value of longitude and latitude will be automatically updated. Now click on OK. Similarly, we will select, we have to select a minimum of 4 points, but we will select 6 points as it gives a good result. Then select another point. We will select diverse points so that our result will be good. Now we have selected 6 points on this map. Now go to start georeferencing. Our map is now georeferenced. We can use it for digitization, etc. for other purposes. Now close this window. Click on discard as we have already saved this file. Now click on new. Now we will learn how to digitize a georeferenced map. Add raster layer. Zoom the map as per your convenience. Go to layer, click, select new shape file layer. Here you can select point, line or polygon. I am first going to show how to digitize an area. So I will select, if you want to digitize an area, then select a polygon. If you want to digitize a road or river, a linear feature, then select line. And if you want to digitize a particular point or location, then select a point. First, I will show you how to digitize an area. So I will select polygon, give some name like whatever name you want to give. Click OK. Save. Now click on district and select toggle editing. All features will become active near them. Now select add feature and zoom the map. As the time is limited, so I will digitize two districts only of Delhi. Click on a point and start digitizing the map. If something goes wrong or you want to delete some point, then just click the delete button on the keyboard. Then it will take you to the previous point. Then you again start digitizing.
Dr. Rashi, there is a query on the YouTube where
Yeah, ma'am.
Mr. Abhi Yanjana Tiwari is asking that after start of georeferencing, no layer is uploaded. There is an error message.
Where? In
She
her.
must be doing it alongside with you. So she's saying that after start of georeferencing, no layer uploaded is the error message.
Okay. Then I think she has made some mistake in georeferencing.
Okay, probably Miss Tiwari, you can start up again, and then maybe you will get it right.
Whether she is using a latitude, a map which has both coordinates latitude or longitude.
Okay,
Or
okay. So you can see this video again. The video will be there on YouTube, and you can practice after seeing this video completely. Abhi, Dr. Rashid, you please continue with the session.
okay, ma'am. After the finishing the digitization, just click right click on the mouse, give an ID, click OK. This district is now digitized. If you want to see the mistakes in digitization, if you want to correct the overlapping of the line, then just go to node tool and click on it and put your cursor on the line which you have prepared using digitization, and click on it and zoom the map, and you can correct the lines by dragging it or by click on a line. If you want to drag a line, click on a node. If you want to change the node, like this. Now click on save. After completing the digitization, we have to save the files, the changes, so that it will be available for next time. As it may happen that we continue this project for next day. So in that case, it is important to save the changes made by, so that it could be available in the next day. Now I will digitize another district. Just click on add feature and start digitizing the another district, another area. While when we want to digitize the another district which is overlapping the boundary of the previous district which we have already digitized, then it is important to click on sniping option. Without this, we cannot clearly match the boundaries of these two districts. So go to the setting and click on sniping option. A window will open. Here you will select vertex to vertex and segment and put a value at the place of 0. Type 5.5. Click OK. Now we can easily join the boundaries of both districts. Wherever you will, there is no need to go to a particular node. Just you put your cursor near it, it will attract the cursor. After finishing the digitization, right click on the mouse and give an ID to the district. Click OK. We have digitized another district. We can make corrections in the line by clicking on node tools, then click on the map. We can drag the first go to setting and put off the sniping option. Click on save. Zoom in the map. By clicking on the toggle editing, we can remove these cross lines from the map. Click on the toggle editing. These cross lines are disappeared from the map. Now I have digitized two districts using polygon. Now I will show you how to digitize a linear feature, road or river, and a point. After that, I will show you the point. Click on district, untick it, and the raster layer will appear. Go to the layer, create layer, select new shape file layer. The same dialog box will open. Select here line, give it a name to it of your choice. I will write here road. Go to add to field list. Click on it. Click OK. Give some name to shape file. Save. Now another option, click on road, will come in the layer panel. Select on road, go to toggle editing, select it, and select add feature. Zoom the map as per your convenient. After finishing the digitization of line, right click on the mouse, give it an identity. Now select another line. Right click on mouse. You may write here too. Click OK. Click OK. Now we have digitized all roads. Go save these changes. Click on Google editing. And right click on the road, go to properties. You can make changes in the line. You can change the color of the line. You can change the thickness of the line by clicking on width. Then click on apply. Then OK. You can see the changes. Now it appears green. Similarly, you can change the color of these two districts by right click on the properties. From here, you can select any color, but and click on apply, but it gives only one color. If we wanted different types of color, then go to select in the air categorized categorized color, or you can use graduated color. Select here ID, then click on classify, then click on apply. You can see that the both are both districts appear in different color. Click on OK. You can also give some name of your choice to the district, to the area. Just click on show labels. Click on ID, apply, OK. You may change the font size and the location of the text. Like you may select bold, italic, any one of them. You can increase the font size by clicking on it. Apply. OK. For digitizing another linear feature, in this case, I will going to digitize river. Then you have to select another layer. Click on layer, create layer, and select new shape file. Click on line, write here river, add it to field list. Click OK. Give a name to shape. Click save. Select toggle editing, select add feature, and start digitizing the river. After finishing, right click on the mouse and give it an identity. There is, if the river has some name, then you can write here. Click on OK. Save the changes. Click on toggle editing. If you want to change the property of river, just right click on it and go to properties. Click on a style. Click on simple line and you may select from here a river. Apply it to the map and click OK. Now we will learn about the use of point, how to trace, how to use points, different types of points for different purposes. Go to add layer, create a new save file, select point, give a name, whatever you want to select, give the name here. I'm going to first point out the location of an airport which is located in these districts. Click on add to field list, click OK. Give a name to the save file. Now this appear on in the layers panel. Click on it and select toggle editing, then click on add feature, then go to that point on the map and put your cursor there and click on it. Give an ID 1 and you may write here the name of that airport or simply the airport. Click OK. Click on save. You can change the icon of this airport and other properties by right clicking on the airport icon. You may select from here SVG marker and select an image, this directory of aeroplane. Just increase, you can increase its size. Apply. You can give a name to the airport by clicking on show labels, then label width if you want to 1 2 3, then give click on ID, and if you want airport name, then click on ABC airport. Click on apply, click OK. You may increase the font size of the text from here. Click apply, OK. I will now trace another point. Go to layer, create new layer, select point. If you want to locate some city as in your state or you can, or any other location or location of a school, hospital, then we have to select different. We have to create different save files for different locations. So in this class, I will locate an important locality or mohalla of Delhi, South Delhi, and these two districts. Give a name here. Click on add fields. Click OK. Then give a name to your save file. Click on save. click, click on toggle editing, then select add feature and go to click on that particular point on map. Just give an ID and put the name of that locality or city. Click OK. Then go to another point and click on it. Put it 2 and write the name of that city or locality or whatever was the point. Click OK. Save the changes. Click on toggle editing. Now you can change the color and shape of the points. Right click on the locality or city name. Go to properties. Go to style. You may select from here any of the shape. You can increase the size of shape from here and change the color of the shape. Click on apply. Now you can change the labels of point. Go to upper section and at the place of no labels, select show labels. Then label width. You may choose the locality name or city name, or you may select ID 123 where I am choosing the locality name. Click on it. You may change its font size. You may make it bold or italic. You can increase the font size of the label. Click on apply. Click on OK. Now our map is ready. We have traced all features using polygons, lines and points. Just click on the polygons and untick the raster layer. The map is ready. A new vector map is ready. Now we will learn how to export this map, how we can put the legends and a scale to the map and other title of the map. So just go to the project, clicked on project properties, just clicked on the projection system, click OK. Then again go to the project and click on new print composer. Give some name to it. Click OK. A new window will open. If you want to change the size of paper, just go to composition and click on it and select A3 size paper. You can zoom it, zoom in or zoom out the paper size. Then how we will uh, make the map to appear on this sheet. Just go to add new map, click on it, put your cursor in a corner here and drag the cursor to the another corner. The map will appear on this composer. If you want to zoom it or want to change this its size, just go to move item content and click on it. You can move the item here and there. You can enlarge the make the item larger or smaller. Just now we will learn how to put title to the map. Go to add new label and make a box here. Go to item properties, just double click on it and write the title of your map. Here I will write you may increase its font size. Make it bold, click OK. If you want to change the position of the title, just click on center. And in case of vertical alignment, click on middle. Similarly, if you want to change the color of your title, you can change. You can put any color to your title from here. If you want to add some secondary title, then again go to add new label and you can make a box and type here the secondary title. In this case, I am giving the year name. Increase the font size. Make it bold or italic bold. Click OK. Put it into center. You may make changes in the color. Just drag this box so to align with the first title. Now we will put another important component of a map, that is a scale. Go to add new scale bar, click on it and just make a box. The scale will appear on the map. You can change the segment of the map from by clicking on this segment. Make and you may change the style of the scale by clicking on the style from single box to double box or any type. If you want to change the font and colors on the scale, you may make it bold or increase the size from here by clicking on font, click OK. And another important component of the map is the direction. So for making direction, just go to add image, click on it and make a box anywhere in the map. Then you may use click on search directories and you can select any one symbol for direction purpose. If you want to change this size, just drag it, or you can you may change the size of the figure from here. Position, you can change the position and size of the figure from by clicking on X and Y.
Yes, Dr. Rashid, are you done with your session? Me presenting.
I have to put some legend and grids. So
Sure, sir. Sure. Please go ahead.
actually network was missed. So
It's okay, sir. Please continue.
okay. Now we have to add legend of the map. Then go to the legend, add new legend, click on it and make a box on the map. All items will appear. You can see in this box that there are several items which are not required in the legend. Then we have to remove these items from the legend. Therefore, go to auto update, click on it and click on the items which you want to remove from the legend box. Click on it and remove items one by one by clicking on minus sign. If you want to change the name of any item, just go to that item and click on the double click on that item and change the name of that item. Click OK. Now we will learn to put latitudes and longitudes on the map. You can change the title of the legend from here. Just you can write the name of the map like you may change the alignment of the title by clicking on center wherever you want. You can make the title bold by clicking on font size. Title, you can increase the font size from here. You may make it bold or increase the size, font size of the legend title. Click on OK. You can change the font size of items. You may change the height and width of the symbols in the legend by clicking on symbol. You may change, increase or decrease the symbol width and symbol height from this pane. You may put a frame to the legend box by clicking on it, and you can change the color of the frame using by selecting on color. You may increase its thickness of the box. Now we will learn how to put the value of latitude and longitude on the map. Just click on grid. Click on draw grids. You may select interval of the grid and offset of the grid from here, these boxes. It depends on the spread, latitudinal and longitudinal spread of the map of the area. You may write here 1. I am putting 1 here as the latitudinal and longitudinal spread of this map is smaller. You may put a frame to the legends coordinates. If you want the coordinates on the map to appear, just click on it. It will appear. You can change the position of the longitudes and latitudes values outside or inside frame from here. You may change the font size of the click OK. You can change the precision of uh, the coordinates. Either you can increase the decimal points or decrease the decimal points by clicking on it. Now our map is ready. We can export this map either in PDF form or image form, just clicking on the icons which is given on the top. Export as PDF or export as image, or we can go to Composer. We can also export. The options exports options are given here. Just click on your choice. I will export this map in the form of image. Just click on it and give a name to your file. Click save. Now our map is ready, as we can see in this window. This we can use this map for different purposes. We can publish this map using different platforms. So now we have finished the practical session. Thank you everyone for attending this class. Thank you very much.
Thank you, Dr. Rashid. I think it is very well explained class that you have taken today. And I think all the teachers who were participating in this workshop will also agree with me that map portion was very well taken by the expert, and I can see a lot of people saying thank you to you. And of course, we will be conducting more of such sessions in the future, and basically more on the mapping of the GIS, because I think that is one part that needs a lot of emphasis. And with this, we are closing down today's session. I thank the expert once again, and all the participants for being so patient and staying with us for 2 days. Your assessment links will be mailed to you. The assessment link will be open till 4 o'clock. So please do make sure to fill up your assessments and send it to us. Based on your performance on your assessment of day 1 and day 2, certificates will be sent to you on your mail IDs. So those students, teachers who feel that they have done their assessments well, you're surely going to get your certificates. So with this, I am signing off for today, and the geospatial training for the teachers is also closed for the day. Thank you so much, Dr. Rashid, once again. Any parting
Thank
words
you.
you want to say to the participants?
What,
Anything
ma'am?
you
Pardon, ma'am?
Anything you want to say to the participants regarding the geospatial technology?
I have explained all things in my lecture. Whatever,
Okay.
if they have any query, I can share my email ID to them.
Sure, definitely. And I'm sure all of you will be practicing on QGIS before you go to your classrooms. And I think we are having a lot of people saying thank you to you. And Mukeshji is thanking you again for such a wonderful webinar. And I must thank you once again. So, with this, I am signing off for today. Thank you all so much. We'll meet again soon. Thank you.
Thank you, ma'am.